All the elements are parallel, no? So we'll do one thing directly. We'll calculate current in each and every element. Each and every element. So what is IL? IC. IC should be equal to. So whenever I'm asking, I should go for RMS only. No, what is VRMS value? 100 by root 2, or this will be 50 root 2. So therefore this will be 50 root 2. I'll write one step. VRMS by XC. VRMS is 50 root 2. XC is how much? It is 4. So 25 by root 2 ampere. Similarly, next IL, VRMS. VRMS is 50 root 2. XL value is 2. 25 root 2. Next IR, VRMS by R, 50 root 2 by 2. 25 root 2. Okay, these are the currents what we are getting. And let's directly get into the some vector diagram, or what you can call phasor diagram. Applied voltage VRMS is what? I'll take it as reference. 0 phase. So we know current IR should be in this direction. And across the inductor, current lags the voltage IL. Okay, we have this much here. So get the resultant current. So we have here X component. X component is IR, which is equal to how much? 25 root 2. Y component, which will be greater, IL or IC? I think IL is greater than IC. So therefore, I'll take it IL minus IC. So 25 root 2 minus 25 by root 2. So 25 by root 2, I'll get it. So this is Y component of velocity. This is X component of current, Y component of current. The resultant current Ix, this is Iy, and this is what call IRMS, or only I, anything. This is a phase angle. So tan phi. Now first we'll calculate what is IRMS. IRMS equal to Ix square plus Iy square. So we'll get this one, the total IRMS will get it. Okay, after this, anybody value of this? Ix square will be 25 anyway will come outside, 2
25 root 5 by 2.
25
Root 5 by 2. Root of 5 by 2, sir.
root of 5 by 2.
Yes.
No, not this much. 25 by root 5.
Sir, not by root 5, sir.
5 by 2.
Into root 5 by 2.
This much.
2 is also in the root, sir.
Yes, sir.
It also 25 multiplied by root 5 by 2. This much.
Yes, sir.
Okay, this is IRMS. So now we know VRMS, RMS will get the impedance. So we'll calculate all the quantities one by one. Let's calculate the tan phi also. Tan phi will be Iy by Ix. Value of Iy 25 by root 2, 25 root 2, 1 by 2. This is a phase angle of circuit. Is it a lead or lag? So that IRMS, where I should show that IRMS? Is it justified? The IRMS, is it a lead or lag? Voltage source will lead the current through source by tan inverse of 1 by 2. Is it justified? Or current lags the voltage? So what we can say here, VRMS leads IRMS by phase angle phi. And what is that phi? Tan inverse of 1 by 2. I'll pick up option C first. I got it. Let's calculate the impedance. What is the definition of impedance? Impedance equal to VRMS by IRMS. VRMS is 50 root 2. IRMS is 25 root 5 by 2. 4 by root 5 ohm. This is the impedance. Power factor of circuit. What is the power factor of circuit? How we should define power factor of circuit? Cos phi. Cos phi will be Ix by, this is something very important. First time the power factor, something I'm writing like this. Otherwise, I used to write R by Z or VR by VZ, VR by VRMS, here Ix by IRMS. Parallel circuits. In series circuits, it will be, let me finish off. Once again, I'll put that one. So what is value of Ix? Ix will be 25 root 2. IRMS value is 25 root 5 by 2. Now you see that in parallel circuits, from the currents what happen, we'll get the power factor. In series circuits, IRMS current also, we have this much. So I'll pick up all these options. So it's some very good information is what we have gathered here. In parallel circuit, something from the current in branch, current in any current Ix, and from IRMS we are able to predict here. Then in series circuit, you see that one. If you look at the series circuit, we used to have like this, no? Please notice different set of formulas. This is VRMS, this is IRMS, this is VR. Power factor, we can also write VR by VRMS. Is it okay? Because according to the impedance triangle, we'll get this is VR, VL. So what is the power factor? Cos phi equal to VR by VRMS from the impedance triangle. In series circuit. In parallel circuit, it will be like this in terms of from current, from Ix by IRMS. So do make observation, say series, parallel. Okay, parallel circuits, if you check the advanced paper, once they've asked, but in some say out of syllabus, but I can ask you because something related to some simple mathematics, we are analyzing it. How you draw impedance triangle here? How you draw impedance triangle? Impedance, see here, what is the biggest problem is like, we are unable to draw that triangle. That's why we are coming for this. So whenever in series circuit, okay, the impedance triangle. In parallel circuits, we are unable to draw them because the vector sum of currents is what we have to take. The phasor sum of currents here, like current in different branches will have different magnitude and phase. You look at XL and XC, IC and IL, they'll all be 180 degree phase. What about IR compared to 90 degree? So drawing impedance triangle, solving, no. If you bring the impedance triangle, if you want to do, you should go for phasor algebra, or better what you say, complex numbers. Addition, multiplication, subtraction, division of numbers which are having both magnitude, direction, we use by complex numbers, no. That mathematics you have to bring it. That is called like a phasor algebra. That'll be more lengthier. So instead, I just took the traditional way of solving the problem. If you are very good in working through complex numbers, yes, you can manage. Getting different? So let's take the next one here. A power factor of circuit